Hello students, this video is designed to help with the week 3 online learning tasks. We're talking about area during week 3, and we talked specifically about area of triangles, trapezoids, other quadrilaterals, and composite shapes. So we're going to try to go over that today. If you have any questions, please make sure that you put them on the Google Classroom site. I will be able to answer any questions that you have, obviously up until Friday, because on Friday they're due. Let's take a look at this first one here. It asks for the area of the triangle below. It's fairly straightforward to find the area of a triangle if you have the base and the height. In this case, you don't have that. You just have the triangle on a grid. There's an easy way to do this though. Pause the video, try this one out, and then see if you got it right. Alright, you can see the first step in answering this question is to draw a rectangle around the triangle so that it covers the whole thing, and to find the area of that rectangle. So the first thing I did was identify that this was 5 units and this was 4 units. So the length times width of that rectangle, in other words, the area of that rectangle is going to be 20 square units. Now the triangle doesn't take up the entire rectangle, so what we're going to have to do is subtract out all the different empty spaces around the triangle that don't have triangle inside of them. So I'm going to subtract out the area of this triangle, and this triangle. It's going to be easier to find those areas because instead of the triangle looking like this, not really knowing what the height or the base of this triangle is, in this triangle we have a right angle, so we can find the base and the height very easily. In this triangle we have a right angle. In this triangle we have a right angle. So we're going to find the areas of these 3 missing triangles, you can think about them like that, and subtract them out of the rectangle. Here I found the area of this blue triangle. It's 3 units and 5 units respectively as its base and its height, which don't really matter which one is the base and which one is the height, because as long as they meet at a right angle, as long as they're perpendicular, it doesn't matter which one is the base and which one is the height. So 1/2 times the base and the height, 5 times 3, well 1/2 times 15 is 7.5. So that's the first triangle's area. Remember, we're going to be subtracting all of these 3 areas from the entire area of the rectangle, which is 20. Here's the second triangle's area that I'm trying to find. I know that 3 times 1 is 3, cutting that in half is 1.5 square units. Remember that all of these are going to be in square units because I'm finding area. If I was finding the distance of something, for example, 3 units from this point to this point, distance is going to be measured in units, whereas area is always measured in square units. If it was centimeters, it would be square centimeters, that kind of thing. Alright, the last area that I have to find is the area of this purple triangle over here. So 4 times 2 is 8, cut that in half, that's 4. So what I'm going to do now, as I talked about at the beginning of the lesson here, is I'm going to try to take the entire area, which is 20 units, and I'm going to subtract out all of the areas that I don't need in order to find the area that I do need. This is otherwise known as finding the area of a shaded region. It is a very common question on the Regents exam, so this is the type of question that you might see. You're trying to find the area of just the shaded region, not worrying about the area of the rest of the region. So I'll show you how to do that now. Alright, you can see that the area of a rectangle is up here. That's 20 units. That's the whole entire thing. Then what I'm going to be able to do is take the area of all 3 of these other triangles, the triangles where the shape is not, that shaded region is not, and subtract them out. So the 20 is the area of the rectangle. I'm subtracting out the area of each of the individual triangles, 7.5, 1.5, and 4, and I get 7. So the answer to this question should be 7 square units. Again, I just want to remind you of this procedure. I'm taking a shaded region that I've been given. I have to draw a rectangle around it and find the area of that rectangle. Then I'm going to subtract out each of the individual pieces that are not part of the shaded region. So I'm subtracting out these 3 triangles to get the remainder, which is the shaded region. Take a look at this question. Hopefully by now, after the description that I gave you, you should be able to try this one out. Pause the video, try this, and then come back to see if you got it right. Alright, here's the answer. It should be 7 units squared. All I'm doing is taking the 4 units here, the 4 units here, and multiplying them together to get 16, and then finding each of the individual triangles that are missing. This triangle is going to be 2 by 3, that's 6, and then cut that in half to give you 3. This one is a 1 by 4 triangle, multiply that together, that's 4, cut that in half to make 2, and then 4 by 2 is 8, cut that in half to make 4. I'm subtracting all 3 of those triangles areas out from the original rectangles area, and you get 7 units. Not bad. Now what I'm going to do is move on to a more complicated picture here. The area of the polygon is a little bit different than the area of a triangle, but not that much different. All I have to do is, again, draw a rectangle around the polygon, and then try to figure out all of the missing parts. I think that you should be able to do this by yourself, so pause the video, try this one out, and then come back to see if you got it right. Remember, all you're doing is drawing the rectangle around the shape, and then figuring out all of the missing areas, and then subtracting them out. All right, here we go. We're looking at now, this time, 4 different triangles that we're subtracting out, but it's the same procedure. I'm multiplying the base times height for all of them, and multiplying that by 1/2, because that is the old boring formula for triangles, 1/2 times base times height. You should also be able to multiply that 7 by 7 to get 49. Then we're going to subtract out all of the areas of triangles from the area of the rectangle. So 49 minus 9 from here, minus 12 from here, minus 0.5 from here, minus 3 from here. I recognize this is a long procedure, but it is not that bad to do. I want to take a look at a couple other questions that seem to have stumped my students. One of them is the area of the parallelogram here. You should have watched the video for this. The area of the parallelogram is very straightforward. I'm going to show you how to do it now. This formula is very, very straightforward. It asks us to find the area of the parallelogram, so we're just doing base times height. One thing to keep in mind is that the base and the height of any parallelogram, the base and the height of any shape, are going to be 2 sides that are perpendicular to each other. And we know they're perpendicular to each other because they have that right angle there. So this measurement is 5. We're calling that the height of this shape. We could also refer to it as the altitude of this triangle and the altitude of the parallelogram. It is at right angles to this side, which is the base. Well, you might be wondering, this measurement here is 8. How come it's not down here? Remember, in a parallelogram, opposite sides are going to be congruent. So if that is 8 units at the top there, at the bottom here, this is also going to be 8 units. So we're using the base times height formula. It's no big surprise. I just wanted to point one other thing out to you. It says 40 units squared. That's the same as saying square units. So I know that the answer here is asking for square units. It's the same as saying units squared. So that was a confusion that some students had. Moving on to the next problem that students had trouble with. This is a composite shape. What I'm going to do is I'm going to try to break it down into 2 simpler shapes, find their areas, and add them together. It's basically the exact opposite of the question that we did before here, where we had to find the whole area and then subtract things out. What I'm doing here is I'm finding multiple areas and then adding them together. Pause the video, try this one out, and then see if you got it right. All right, just from an analytical standpoint, I wanted you to see this. I took the purple shape, which is the combination of a rectangle and a triangle, and I cut it up into 2 simpler shapes. This is the area of a rectangle. That's the rectangle that's here. It's a very long, thin rectangle. And here we're going to find the area of the triangle, which is the shape that's here. All right, if you haven't already done so, please draw these 2 shapes on your paper and then try to figure out what the dimensions are and what the areas are for these 2 shapes. Pause the video, try that out now. The rectangle was very straightforward. It had a 1 and a 12 here, so I was able to use that. The triangle I wanted to walk you through because this bottom says 5 units, and over here it says 6 units. Well, keep in mind that there is 1 unit for the top of this rectangle, which means the bottom of this rectangle also has 1 unit of measure on it, which means there's something else on this diagram that has 1 unit of measure on it. It's here at the bottom of the rectangle. So this piece has 1 unit. In other words, this part of the bottom of this shape has 1 unit in it. If the entire measurement has 6 units, that means the bottom of the triangle is only going to have 5 units for a total of 6 units from here all the way to here. That's probably the most complicated part of this question. Other than that, it's just finding the area using the methods you know how. All right, by now you should be able to find the area of a rectangle and the area of a triangle by yourselves without parental supervision or anything like that. But you should be able to get those 2 areas and add them together to give you 42 square units. One question that students sometimes ask is, oh, well, I got the 5, I got the 12 in here. What happened to the 13? Good question. Remember that the area of a triangle is based on 2 different measurements, the base and the height. In this case and in all cases, the base and the height are 2 sides of the triangle that have to meet at a right angle. This right here is the right angle that I'm talking about. They're perpendicular sides, which means they meet at a right angle. We know it's a right angle also because this is a right angle here. And since it's a rectangle, this is a right angle here. And since we have the supplementary angle theorem that says that 2 angles that form a straight line must equal to 180 degrees, if this is 90 degrees, this must also be 90 degrees or a right angle. Anyway, so you should be able to figure out that this side is the hypotenuse of that right triangle, which means I'm not going to use it in my area calculation. The area is just the base times the height. All right, moving on. There's one other question that I wanted to talk about with composite shapes, and that's this one. There's 3 different shapes here. You should be able to try this by yourself. Remember, we're finding the areas of the individual shapes and then adding them together. Pause the video, try this one out, and then see if you got it right. What we did here is we broke this composite shape into simpler shapes, a triangle, a rectangle, and a triangle. Both of these triangles are right triangles because of this right angle here, so I'm able to use 1/2 base times height because these two sides are perpendicular to each other. So 2 times 2, that gives us 4. Cut that in half, that's 2. For a rectangle, we don't have to cut it in half, it's just 2 times 2, which is 4. And for this triangle, 4 times 2 is 8. Cut that in half, that becomes 4 units squared. I'm adding all of those together because it's a composite shape made up of 3 different simple shapes, this triangle, this square, and this triangle. Adding them all together should give us 10 square units. Not bad. There's one more type of problem that I want to go over, and it is the problem that is talking about the area of trapezoids. Another example of a formula that you should know. This is the area of a trapezoid. I will show you the formula, and then I will show you how it is used. All right, for any trapezoid, and that's a quadrilateral in which there is one pair of opposite sides that are parallel and one pair of opposite sides that may or may not be parallel, that's going to be the first base plus the second base. In this case, the 2 parallel sides are the bases, and in all cases, the 2 parallel sides are the bases, divided by 2. So I'm finding the average of the 2 bases. And then I'm going to multiply that by the height, which is the distance between the bases. In this case, it's 4 meters. So I'm simplifying that formula into b1 plus b2 over 2 times height. You've seen this formula before, probably, if you watched the Khan Academy videos, and you would have seen it in class as well. Now I'm going to show you how it looks in action. All right, we've set out the formula, the b1 plus b2 divided by 2 times height. And then we've identified the 2 bases as 7 and 4. Keep in mind, it doesn't matter which one you choose as the first base and which one you choose as the second base, because all we're doing is adding those 2 numbers together. That's the commutative property, which allows us to switch those around. It could have been 4 plus 7, wouldn't have made any difference. That's 11, so I divide that by 2, and I get 5.5. And I'm still going to multiply that by 4. 4 is the height. I'm being very specific here. The height is the distance between the 2 bases that is perpendicular to the 2 bases. So the first base is 4, the second base is 7, and the distance between those 2 bases is 4. So I'm multiplying those 2 numbers together to get 22 meters squared, otherwise known as square meters. Remember that I talked about this in the previous problem. It could talk about square meters, or it could talk about meters squared. All right, that was the video on, or the first video, I should say, on week 3 area. If you have any other questions, please make sure to reach out to me and email me those questions. I will answer them in a second or third or fourth or however many videos it takes. All right, students, good luck studying.